Let's now consider the quotient rule for radicals and how it's used to simplify radicals. The quotient rule for radicals says the nth root of a over b equals the nth root of a over the nth root of b. For example, the square root of 4/9 equals the square root of 4 over the square root of 9, which equals 2/3. Now consider the square root of 45 over 80. Notice that the radicand can be simplified. We get the square root of 5 times 9 over 5 times 16, which simplifies into the square root of 9/16. Using the quotient rule for radicals, we get the square root of 9 over the square root of 16, which equals 3/4. Finally, consider the square root of x to the 14th over y to the 12th. The radicand is already simplified, so we apply the quotient rule for radicals. The square root of x to the 14th is absolute value of x to the 7th. We need absolute value in case x is negative. The square root of y to the 12th is y to the 6th, which we know is non-negative since 6 is even. We can summarize a general process for simplifying radicals using the quotient rule. First, simplify the fraction in the radicand if possible. Second, use the quotient rule to write the expression as a quotient of radicals. Next, simplify the radicals. Finally, repeat these steps as needed until no factor of the radicand contains a power that is a multiple of the index. Let's apply the process to some examples. Instructions on these problems will be to simplify each radical expression. First, consider the square root of 45x to the 5th over y to the 4th. Since the radicand is already simplified, we apply the quotient rule. Next, we need to simplify each radical. We apply the product rule to the numerator, and the denominator simplifies easily. The square root of 9x to the 4th is 3x squared, and 3x squared is non-negative, so we don't require absolute value. We get 3x squared times the square root of 5x over y squared as our final simplified answer. Let's consider a second example with a cube root of a quotient. This time, the radicand can be simplified. Essentially, we can cancel 2x squared y squared from both the numerator and denominator. Now we apply the cube root to both numerator and denominator using the quotient rule for radicals. To simplify the numerator, we use the product rule for radicals and factor out perfect cubes. The denominator is the cube root of 27, and 27 is 3 cubed. Finally, we get 2xy times the cube root of y squared over 3 as our final simplified answer. Simplification of a fourth root of a quotient is similar. First, the radicand can be simplified. We cancel 5x cubed y cubed from both the numerator and the denominator. Next, we apply the fourth root to both the numerator and denominator. We can simplify the numerator using the product rule and factoring out fourth powers of each factor. Notice that 16 is 2 to the 4th, so the denominator simplifies. Simplification of even roots of even powers requires absolute value to ensure that the value is non-negative. However, since we have a fourth root of x, we can assume that x is non-negative and drop the absolute value on the factor of x. Recall that in general, to simplify radicals, we want to factor out the largest perfect power for the index. Let's consider some final examples in which we use the quotient rule for radicals backwards. Simplify each expression. Now we start with a ratio of radicals. To simplify, we will eventually need to eliminate the radical in the denominator. We can use the quotient rule for radicals to write this as the square root of one fraction, and now the radicand simplifies easily. 48x to the 7th over 3x is 16x to the 6th. The square root of 16x to the 6th simplifies to 4 times the absolute value of x cubed. But because we originally had the square root of 3x, it's safe to assume that x must have been non-negative, and the absolute value is unnecessary. Now let's consider a ratio of cube roots. Recall that negative quantities under odd-indexed roots do not present extra issues. We could try to simplify each root separately. However, the quotient rule for radicals allows us to apply the cube root to the ratio, allowing for easier simplification. Negative 108 divided by 2 is 54. And 54 can be factored into 3 cubed times 2. That is, negative 108 over 2 is negative 54. And negative 54 is a negative 27 times 2. Using the product rule for radicals and recognizing that negative 27 is negative 3 cubed, produces a simplified negative 3 times the cube root of 2. Finally, let's consider a ratio of fourth roots. Again, we apply the quotient rule for radicals and simplify the radicand. We get the fourth root of 16x to the 6th. Factoring fourth powers out of the radicand allows for simplification of the radical. Evaluation of the fourth root of x to the 4th gives us an absolute value of x. However, looking back at the original problem, we can see that x had to be greater than or equal to 0 since x is under an even-indexed radical. So we could drop the absolute value on x. In addition, using rational exponents, we notice that the fourth root of x squared is x to the 2 over 4 power, which is x to the 1/2 power, which is the square root of x. So our simplified answer is 2x times the square root of x.